here to present C project presentation LSB steganography. Coming to introduction, steganography is derived from Greek words steganos means covered and graphia means writing. It is the art and science of the hiding information within the other. Basically, steganography is a practice of concealing a file, message, image or video within the another file, message, image or video. Next, coming to why it is required to enhance the data security and privacy protection. To enhance the data security, steganography allows for the secure transmission of information by hiding it with another within the other seemingly innocuous files such as images, audio, video. This makes the hidden data less likely to be detected by unauthorized parties, adding an extra layer of security beyond encryption. Privacy protection. In a world where data breaches and surveillance are prevalent, steganography helps protect personal and sensitive information from being accessed by unintended recipients. It ensures that private communication remains confidential. Next, coming to background of the steganography. As I mentioned, steganography is the art and science of hiding information within the other non-secret text or data, unlike cryptography. The historical content, steganography has rich history that dates back to ancient times. In ancient Greece, Herodotus wrote messages tattooed on shaved heads of slaves. Once they grew back, they would deliver the message. Next, coming to World War II, in invisible inks, microdots, and other forms of steganography were used to communicate. In modern era, with the advantages of digital technologies, steganography has evolved to include hiding information in digital media such as images, audio files, and even network protocols. Next is types of steganography. There are many like text steganography, image steganography, audio steganography, and video steganography. The text steganography is embedding secret messages in a text files using various techniques like changing formatting, using invisible characters, and others. Image steganography. The most common form involves the altering the least significant bit of pixel values in an image file to encode hidden data. Audio steganography, embedding information within audio files by altering audio samples. Techniques include LSB coding, face coding, and echo hiding. Video steganography, hiding messages in video files by modifying the properties of video frames. Next is the requirement. The application must accept an image file, say .bmp file, along with a text file which contains the message to be stick. Analyze the size of message file and data part of the .bmp file to check whether the message could fit in the provided .bmp image. The application should provide an option to decrypt the file. This has to be a command line application because all the options has to be passed as command line argument. Image steganography. Though there are different possible methods available, we would go with the digital steganography. In digital method, the message is concealed within the lowest bits of images or sound files. The current project expect us to implement LSB image steganography on a .bmp file. As we consider the LSB, consider the byte with value 0. As we can see the binary value of 0, if we change the LSB bit by 0 to 1, it doesn't change the magnitude of the number as much. Hence it is called least significant. If we change the MSB bit by 1, it changes the magnitude of the number to the double. Hence it is called most significant bit. Coming to image. A file which contains picture elements is called pixels. Fixed number of rows and columns of pixels. These pixels would be grouped along with different informations and forms a format. Pixel is the smallest individual element holding adequate values that represent the brightness of a given color at any specific point. A pixel also can be said a smallest addressable element in all points addressable display device. The intensity of each pixel is variable. And in coloring image systems, a color is typically represented by three or four components. Project. We will go with the BMP file. The BMP file format handles the graphic files within the Microsoft Windows OS. Typically, BMP files are uncompressed and therefore large and lossless. Their advantage is simple structure and wide acceptance in Windows programs. Coming to design and coding. First, we will check the option there which is encoding or decoding. If the option in the command line is option E, then we will check with the file is .bmp or not. If not, then we will not do. And next, we will check is the secret file provided or not. And next, we will check for the calculate the size of the secret file. And next part is string user magic string empty. And if it is yes, print error message and no, set magic string signature and calculate the new size for encoding and check will the secret message will fit and en- and encode magic string size and next encode magic string, otherwise print error message and stop. And next is encode input file extension in the extension that is .txt and encode the secret message and copy the remaining bytes to output file and stop it. And coming to the decoding, in this check with the option that is -d or not in command line argument. And next is the file is .bmp or not. If not, print the error message. And next is the output file name is provided or not. If it is provided, then create a file with provided name, otherwise create a with default name. Next, start decryption and stop it. Here is the output of the encoding. The commands is gcc start.c and for the output we have to give /a.out -e, which is option encoding or decoding. Next is the beautiful.bmp is file and secret.txt where the secret message is present. And as we can see, this is the output. Selected encoding, read and validation is success, opening files for encoding success, and the width and height of the file is 1024 bytes and 768, and capacity checking success. In the BMP file, the first 54 bytes will be uh, header files, and next we have to encode a magic string which is 16 bytes hash and star, and next we have to encode the .txt extension size which is 32 bytes, and again we have to encode the extension data which is .txt, and next we have to encode a secret file size secret file size which is 32 bytes again, and next we have to encode a secret file data and copy the remaining data as it is. We have to encode a magic string because while decoding, the decoder will get to which file we have to decode, and also the .txt size and .txt we have to encode because the decoder would know while decoding which file we have to decode. decoding. As we can see the output of the decoding, it is first we have to uh, check the .bmp file or not. It is read and validation is success, and open files for decoding is success, and the decoded part for magic string is hash and star, which is success, and decoding the extension size and decoding the extension data, which is .txt, and decoding the secrets size success, and decoding the secret message data, which is basapa, and decoding the secret file data is success. Coming to application, the steganography is used in many various purpose, like military purpose and in intelligence agencies, online elections, internet banking, medical imaging, and so on. Challenges faced, uh, first one is the robustness. The hidden message should remain intact even if the carrier medium undergoes transformations like compression, resizing, or format changes. Capacity. The method should provide enough space to embed the secret information without compromising the quality of the carrier medium. Security. The technique should ensure that hidden information is not easily detectable by unintended recipients. Imperceptibility. The presence of hidden data should not be noticeable to the human senses. Coming to the summary of this project expects us to encode a message such a way that quality of the image doesn't change much. As we can see, the original file and encoded file is same. Let us see the execution of this project. These are the files used in this project, which is common.h, decode.h, encode.h, output.txt, secret.txt, and decode.c, encode.c, and main.c. As we can see that if we are not giving the options, that is encoding or decoding, it asks for the options, like we have to do encode or decode. Next we have to give an option in command line argument, which is encode E, option E. Now we can see that output of encoding, which is selected encoding, and as I mentioned before, which is the read and validation, BMP header copy success, encode magic string success, extension data, secret file size, secret file data, and last copy the remaining data as it is. Coming to decoding part, now you have to run all the files, and next is have to check for the output dot slash a dot out stego dot bmp. Again, it asks for the option -e or -d, which is encoding or decoding. -d for decoding. As we can see the output of the decoding, first one is it selects for decoding, and read and validation is success, which is it checks for the .bmp file or not, and again it opens the file for decoding, and hash and star are the magic string, and decoding the extension size, and decoding the extension which is .ext, and decoding the secret size success, which is the as we can see here, and decoding the secret file data. In this function, get image size for VMP, we will get the image size which is width and height, and open files will open and check operation type which is -d or -e, and next read and validation, we will check for the file is .bmp or not, and in check capacity it fits or not, and in copied bmp header we'll copy the 54 bytes header, and next is encode magic string which is hash and star, and next is encode data to image. In I equal to 0, I is less than size, here we will run for loop for twice, which is hash and stars magic string length, and it calls the function encode byte to lsb, and we will change the lsb bit of the magic string, and next we'll encode secret file extension size which is 32 bytes, and encode size to lsb which is 32 bytes, secret file extension again 32 bytes, secret file size 32 bytes, secret file data it is 7. What is the it is based upon the secret message we have given, and last which is copy the remaining image data. Same as encoding, here we will read and validate for decoding, and option decode the magic string, decode the data from image, decode byte to lsb, this is the steganography project. Thank you.